Good day, everyone. Today, we are going to discuss solving equations transformable to quadratic equations. There are equations that are transformable to quadratic equations. These equations may be given in different forms. Once these equations are transformed to quadratic equations, we may now use the techniques that we have learned in our previous lessons, such as extracting the square roots, factoring, completing the squares, and using the quadratic formula. Let us now start solving quadratic equations that are not written in standard form. In our first example, we have x times the quantity x plus 3 equals negative 2. Some might think that this is not a quadratic equation. However, if we simplify and apply distributive property, we are going to have x squared plus 3x equals negative 2. But how did we get that? So first, we need to multiply x by x. That means it's x squared. And x times 3, that would give you 3x. However, this is not yet in standard form. So to change this quadratic equation to standard form, we now have x squared plus 3x plus 2 equals 0. This is now a quadratic equation and we can solve this through factoring. But how do we factor? So to factor, we need to find a number that when multiplied will give you 2, but when added will give you 3. So the factors are x plus 2 times x plus 1. Notice that 2 times 1 is 2, and 2 plus 1 is 3. Next is to equate to 0 and solve. I will have x plus 2 equals 0 and x plus 1 equals 0. X plus 2 equals 0 will be x equals negative 2 and x plus 1 equals 0 will be x equals negative 1. Therefore, the solution is negative 2, negative 1. Now, let us move on to solving higher degree equations transformable to quadratic equations. For our example number 2, we have here x raised to 4 minus 8x squared plus 16 equals 0. This is an equation of the form au squared plus bu plus c equals 0. But this is not a quadratic equation. Notice that the degree here is 4. So we have to transform this into a quadratic equation. But how are we going to do that? So first, we let u be equal to x squared. So if u is equal to x squared, then we can change x raised to 4 to x squared raised to 2. Negative 8x squared will be changed to negative 8 times x squared plus 16 equals 0. Again, u here is equal to x squared. So when you substitute it, it will have u squared minus 8u plus 16 equals 0, which is already a quadratic equation. Now, we can solve this through factoring. The factors of u squared minus 8u plus 16 equals 0 are u minus 4 times u minus 4. Notice that negative 4 times negative 4 is 16, and negative 4 plus negative 4 is negative 8u. Now we have to equate and solve it. U minus 4 equals 0, and u minus 4 equals 0. Therefore, u equals 4, and u equals 4. However, we say that u is equal to x squared. So going back, we now have x squared equals 4. because u now is replaced by x squared. So x squared equals 4 and x squared equals 4. So when you extract the roots, the square root of x squared is x, and the square root of 4 is positive negative 2, and so with the other side. That means that the solution set is negative 2, 2. Let us now have example number 3. We have quantity x squared minus 2 squared minus the quantity x squared minus 2 minus 6 equals 0. Some may think that this is very difficult, but actually, this is very easy. All we need to do is to look at these terms. Notice that x squared minus 2 and x squared minus 2 here are the same. That means we can let u be equal to x squared minus 2. Since u is equal to x squared minus 2, this will be replaced by u squared minus u minus 6 equals 0, which is already a quadratic equation. Now we need to factor. So we have to look for a number that when multiplied is negative 6, but when added is negative 1. The factors are u minus 3 times u plus 2. Notice that negative 3 times 2 is negative 6, and negative 3 plus 2 is negative 1. This time, we have to equate to 0 and solve. We are going to have u minus 3 equals 0 and u plus 2 equals 0. U minus 3 equals 0 will be u equals 3, and u plus 2 equals 0 will be u equals negative 2. But this is not yet the final answer. Remember that we let u be equal to x squared minus 2. Now, if we resubstitute, we are going to change u to x squared minus 2 and u here also with x squared minus 2. We will have x squared minus 2 equals 3 and x squared minus 2 equals negative 2. Simplify. We'll have x squared equals 3 plus 2 and x squared equals negative 2 plus 2. 3 plus 2 is equal to 5 and negative 2 plus 2 is 0. That means I have x squared equals 5 and x squared equals 0, which is a quadratic equation. Now, we need to use extracting the roots. When you extract the roots of x squared, it will be x, and the square root of 5 will be positive negative square root of 5 since it is not a perfect square. The square root of x squared is x, and the square root of 0 is 0. Therefore, the solution set is 0, negative square root of 5, and positive square root of 5. Now we proceed to solving rational algebraic equations transformable to quadratic equations. For our next example, we are going to have 2 over x minus x over 6 equals 2 over 3. But how are we going to solve this? First thing we have to do is to identify our LCD. Notice that our denominators are x, 6, and 3. So the LCD will give you 6x. So we need to multiply every term or each of the term to the LCD 6x. Doing that, we'll have 6x times 2 over x minus 6x times x over 6 equals 6x times 2 over 3. So since we are multiplying fractions, there are terms that we can cancel out. So we can simplify x over x as well as 6 over 6. Doing that, we are going to have 12 minus x squared equals 4x. But how did we get that? So notice that in multiplying 6x by 2 over x and x will be cancelled. That means 6 times 2 is 12. Next, 6 and 6 will be cancelled. That means x times x will give you negative x squared. In this example, I have here 6x times 2 is 12, and 12 divided by 3 will give you 4x. But this is not yet in standard form. So to change this into standard form, we are going to have x squared plus 4x minus 12 equals 0. The next step is to factor. So what are the factors of x squared plus 4x minus 12? The factors are x plus 6 times x minus 2. Notice that 6 times negative 2 is negative 12, and 6 plus negative 2 is 4. Now we equate this to 0 and solve. X plus 6 equals 0, and x minus 2 equals 0. X plus 6 equals 0 will be x equals negative 6, and x minus 2 equals 0 would be x equals 2. Therefore, the solution set is negative 6, 2.